So after you glue it down, if you need to, you can write a little reminder. This is what we're going to look for when we talk about what is a function. When you take your quiz on September 3rd, this is the first question. Is it a function? You're going to have ordered pairs. You could have a graph. You could have an equation. These are your rules to know if it is a function. Functions do not repeat in the X. So we're going to take a moment and we're going to look at these examples. So we're going to call this one H, this one is I, and this one is J. I don't know why it's not there. So we're going to look at these 11 examples that you glue down, and we're simply going to say, yes, it's a function, no, it's not a function. Now, on the quiz, it asks you to explain. If you say no, you have to tell me why it's a no. You don't have to say why it's a yes, but you do need to tell me why it's a no. Are we ready? Okay, let's look at A. Again, I'm only looking at X. That's these numbers right here. That's the first number in the order pair. Are any of those green highlighted numbers the same? So that means that this is a function, and you would say yes. If you get an order pair, a set of order pairs where all the X's are different, that's a yes. It does not matter if there's a repeat in Y. That's not what we're looking at. We're only focusing on X. Let's look at question B. Same thing. Look at these 4 numbers. Any of those green numbers the same? No. So again, that is a yes. But when we get down to C, that's our first no. Now, when you see this on the quiz, because it's a no, you have to tell me why it's a no. And what are you going to say, Deron?
No, because 2 of the X's are both.
Yep, 2 of the X's are the same. And I'm very, very flexible on that no. You could say no because the domain repeats. You could say no because I have 1 twice. But you got to tell me something. All right, now let's look at these next set of equations. We're going to focus in on Y. And you all do know that this is the same as Y, right? I don't need to explain that that's a Y. F of X is the same as Y. This has a 1, this has a 1, that has a 1. Every variable in number has an invisible 1. 1 is an odd number. As long as that exponent on Y is odd, then it's a yes. So D, E, and F are all yeses. The exponent on Y. Yes, because if you have an even exponent on Y, it is going to cause you to have repeats in your domain. Now, the end of chapter 2 is when we're going to graph, and you'll be able to see that. But G is the only one that has a 2, so that's a no. All right, H and I.
So when I give the excuse, it would be no because Y has the exponent of 2.
Perfect. Perfect. All right, I don't know if they talk about this in Algebra 1. I have not taught Algebra 1 in 17 years, but these are called relation maps. Have you all seen these before, these 2 little oval things?
Yeah.
All right, well, let's just talk about it real quick. This first oval is X. The second oval is Y. Okay, as long as every point in the X oval only has 1 arrow branching off from it, it is a yes. This one is a yes. That's a function. But I is a no, and I'm going to explain to you why. I'm going to assign some random numbers to these dots. Let's say that this dot represents the number 1, And over here, that's a 2 and a 3. What that means is I have an ordered pair at 1, 2 and 1, 3. Because that 1 has 2 different friends. Can't have that. 1 is going to repeat. So that one is a no. And when you get down to a graph, have you all heard of the vertical line test? All right, if you can draw a vertical line and it crosses it more than once, it's a no. So when I look at K, I could draw a vertical line, it crosses twice. That's why K is a no. But J is a yes. All right, so that's the first piece of 2.1. Looking at and determining if it's a function. I don't know if your quiz is going to have ordered pairs. It can have graphs. It can have equations. It can have maps. It can have one of each. Any questions about how to look at that and determine if it's a yes or a no? All right, now we're going to glue down our second thing, which is finding the domain. So we're going to do 9 things with this cutout, but I mean, it doesn't really matter. You can either go to a fresh page or you can, you know.
What's today's date?
Today is August 21st. So I think I'm a little weird because I'm the only pre-cal teacher that calls it red lights, but that's how my brain works. The way I think about it is everything starts off with all real numbers. And unless you see one of these 2 situations happening, it's going to stay all real numbers. The first thing that you cannot do, because it is impossible to do, is divide by 0. You cannot divide by 0. If you don't believe me, ask your calculator. Pick any number and try to divide it by 0. Because of that, we can't have a 0 downstairs. Anytime your calculator gives you an error, it's a red light. Now you can take 0 and divide it by a number. If you take 0 divided by 5, your calculator will say 0. But if you put 5 divided by 0, you get an error. That's why it is a red light. The second red light is square roots. You cannot take the square root of something that is negative. If you don't believe me, test it in your calculator. If you type in the square root of -3, you get an error. So if you have a square root, it has to be greater than or equal to 0. So what we're going to do, we're going to look at 9 different equations, and we're just going to state the domain. And it'll go fast. I know that sounds like a lie, but it's not. Are we ready? So I'm going to give you a moment to copy down these 3, and while I'm doing that, I'm just going to collect up the glue sticks. So example 2 is state the domain in interval notation, and those are our first 3 examples. You want to look on the floor and make sure I didn't miss any. Thank you. Okay, so looking at A, do we have any red lights? Red lights are a fraction with X in the bottom or a square root. Do we see that in equation A? No. So we don't have a reason to stop. domain is all real numbers. Let's look at B. Do I have a fraction with an x in the bottom? Do you have a square root? Square root. No. We have a square, but that's not a square root. That's not a green light. All real numbers. 3 has a square root. So what that means is this piece has to be greater than or equal to 0. So when you see that, we need to make an equation and solve it. So let's go ahead and solve that for x. Same rules to solve an inequality applies. First thing we're going to do, subtract the 2. Now I have to divide a negative by a positive. Do I need to flip my inequality? No. So x has to be greater than or equal to negative 2/3. Now you do not have to graph this, but I'm going to just show you what it would look like if it was graphed, because I think that might help some of the people who struggle with interval notation. What this means is I'm going to start at negative 2/3 and then I'm going to the right. Just like you read a book from left to right, that is how you read an interval. The smallest number on my interval is negative 2/3. Because it equals that, it gets a hard bracket. And it's going towards infinity. Infinity always gets a soft bracket. This is the only way I will accept your answer when you take your quiz and or test. Everything we do is in interval notation. All right, any questions about the first 3? Ready for the next 3? All right, I think for this one, we should copy it down one at a time because these might take a little bit more space. So let's just copy down D. And then we'll go to E, and then we'll go to F. So D says y equals x plus 2 over x minus 1. And this is the first time we have a fraction with the x in there. An x in the bottom, to be more specific. I don't care about this. This has nothing to do with my domain. It is your denominator that controls our domain. So this x minus 1 cannot equal 0. And when I solve that for x by adding 1 to both sides, I get that x cannot be 1. So let's talk about how we write that in interval notation. So I'm making my little number line. Goes from negative infinity to infinity with a 1 in the middle. This cannot equal, so I'm putting an open circle here, not a closed circle. So think of this as a stick that I broke in half. And I made the break at 1. So right here, this is the first half of my domain, which says that I can go from negative infinity to 1. Both sides get a soft bracket though. This union means break.
How did the other one get a hard bracket and this one gets a soft bracket?
Okay, so when we go to this one, that's a square root. It can equal 0. It just can't be negative.
Okay.
So that's why we can have a hard bracket. But if you have an x in the bottom, it cannot be hard. It has to be a soft bracket. All right, and then the second half starts here, which would be what? What's the rest of my domain? 1 to infinity. Always smallest to largest. You read it like you read a book from the left to the right. All right, if you haven't already, go ahead and copy down E. I know, it's been a long day. Nervous.
Yeah, first verse we started.
Yeah. Okay, so the reason why this one is icy is because we have a quadratic in the bottom. So what that means is, first of all, again, I don't care about this. This has nothing to do with my domain. That means I have two numbers in my domain that I have to eliminate. So I'm going to factor this down. This would factor down to x plus 3 and x minus 3 because that's the difference of squares. So that means I have two numbers that x cannot equal. So we got to take our stick and break it 2 times. So x plus 3 cannot equal 0 and x minus 3 cannot equal 0. So that means that x cannot be negative 3 or positive 3. So I'm going to draw my number line. Again, this is optional, but I just have found that students understand it a little bit better when they can see it. I have an open circle and an open circle. So now I have this piece of my interval, and then I have the middle, and then I have the right. So I'm going to break my domain. I'm going to have 3 sets of parentheses. So let's start off with the far left. Negative infinity to negative 3. Close the parentheses. Both sides are soft. Union. Then in the middle, negative 3 to positive 3. Both sides soft. And another union. That means break. 3 to infinity. It's not so bad, right? Just 2 red lights. That's all we got to think about. And unfortunately, those red lights are going to carry us through the whole semester. We're going to be...
That's the answer you're looking for?
That's the answer. That's it. All right, last one, F. Well, I didn't mean to say last one. That's a lie. Last one on this slide. Then we got one more slide and then we done. Okay, so this is like a double whammy because we got a x in the bottom and it's under a square root. So we took both of the red lights and put it together.
So we're crossing out the 30.
Yep, we don't care about that. That ain't got nothing to do with nothing. Well, it has nothing to do with the domain. So normally when I write my interval, I would say x plus 5, because it's a square root. Normally for a square root, I would say x plus 5 has to be greater than or equal to 0. But this one is in the bottom. It's in the denominator. So which one of these pieces do I need to take away? The equal to part. That has to go away. Now, I want to just say this, and you don't have to write this down because I do want to make sure that my averages continue to be high, is that if it was written like this, then I would keep the equal. But because it's in the bottom, I have to take it away. So that's important that you understand the difference. It's because it was a square root in the bottom. That's why we dropped the equal.
And so since it's a square root, that would make it a hard bracket?
It's only a hard bracket when it can be equal. So can this one be equal?
Okay.
No. So when I solve this, I'm subtracting the 5, which means x has to be greater than negative 5. Which means I have an open circle and it's going this way. So this one is going to start at negative 5 and it never stops. So because it's in the denominator, nothing can be equal to 0. We cannot put any hard brackets. All right, last slide. G, H, and I. We'll copy them down one at a time. Let's start off with G. So what I want to make sure you understand is when we are doing the domain, this is not like what we did yesterday where we had to find the x-intercepts. No, this is not that. If I'm asking you for the domain, the only thing that matters is this, because that's what's under the hood. This right here and this right here are irrelevant. So what I want you to do, because this one is not in the denominator, is I'm going to set that greater than or equal to 0 and solve that for x. Keeping in mind that when you divide both sides by -4, what happens? It flips.
And you don't drop the equals or something?
Nope. And why don't we drop the equal to this time?
Denominator.
It's not in the denominator of a fraction. Only if it's in the denominator. So I'm going to subtract the 1. And then I'm going to divide by -4 and flip it. So that means that I can only use numbers that are less than 1/4. This is included. So if I'm reading this as an interval from left to right, -infinity to 1/4, this side gets a parentheses, and we can have a bracket. All right.
Why did it flip?
It flipped because we divided both sides right here by a -4. I had to divide both sides by a negative. You only flip it when you have to divide by a negative. All right, go ahead and copy down H. And then you just ask yourself, do you see any red lights? So do we see any? We got a fraction with an X in there in the bottom.
No.
We have a square root. So what does that mean? What's our domain?
Negative infinite, positive.
Yep, -infinity to positive infinity. All right, last one for today. I. Yeah, one flag with 2 pieces. So that means I got 2 things that I have to take out of my my domain. We can't cancel it because it's an x plus 4 and an x minus 4, so we can't cancel that. And even if we could, we wouldn't, because we're gonna talk about that later. But we're not canceling nothing. So here, this tells me I have 2 different things that I need to take out. So I'm just gonna set them. Remember that these cannot be 0. So go ahead and solve both of these to figure out what are the 2 numbers that x cannot be. There are 2 different numbers that x cannot be. So my first one, when you subtract 1, you get that x cannot be -1. I got to take that out. The second one, I add the 4, I get that x cannot be 4. So that means, and I'm going to put -1 because it's smaller than 4. That's why I put that one down first. So we have no brackets. This is open, this is open. So I want you all to try to write your domain by yourself. You got to write, it should be 3 sets of parentheses. You got the green piece, the pink piece, and the blue piece with a U in the middle. All right, do you all agree with my answer? Kind of ran out of space. I had to scrunch my little infinity over there to the side. Okay, I'm just going to have you write down the first examples for tomorrow, but that is the end of today's lesson. Thank you all. I appreciate it. Go ahead and copy these down. And then you can put away your notes.